Okay, let's have a go at some paper 2 MCQ multiple choice questions. So again, this is from that collection by Mr. Hadi Othman. If you want his local phone number, let me know. Just want to point out here that you don't need to know about this fourth state of matter. It's not in the syllabus. You're not required to know about it. Also, just in case anyone's wondering, the particular nature of matter, there's a mistake there. It's the particulate nature of matter, as mentioned here in this title. So let's start with this topic. Number 1, when water is warmed, what happens to its molecules? Well, the movement of the molecules becomes faster, so we can cancel out these. But the size of the molecules stays the same. Okay, so faster and stays the same. The size of the molecules is only going to change if the substance is different. Number 2, diagrams 1, 2, and 3 represent 3 states of matter: solid, liquid, and gas, as you can see. For which states can diffusion be demonstrated by using simple laboratory apparatus? Well, according to your syllabus, you are not required to demonstrate diffusion in solids, although it does and can happen. Like, for example, in agar jelly, a drop of ink will spread out. But like I said, you're not required to demonstrate that using simple laboratory apparatus. So the only ones are the fluids, which are gases and liquids. So gases and liquids are number 2 and 3. So the answer is C. Number 3. How can crystals be obtained from a hot concentrated solution of a salt? So remember crystallization, 2 main steps. Heat the solution until crystallization point or saturation point. Cool, allowing the crystals to form. So here, they've already got a hot concentrated solution of the salt. So all you have to do now is cool. Okay, now cooling by itself is not an option. Okay, so the closest one is cooling and then filtering. The reason why they add filtering is because when you cool down, you're going to get a mixture of crystals and also some of the leftover liquid or solution. So if you just want the crystals, then you can filter them to separate them from the rest of the solution, or you can decant, which means pouring off the liquid gently, leaving the heavy settled solid behind. So you can do that. And then if they want pure dry crystals, you can wash with distilled water and then dry using a suitable drying method. Let's do number 2. Some sugar is dissolved in water. Which diagram shows how the particles are arranged in the solution? So sugar is completely soluble in water, so it's going to form a homogeneous solution where the particles are evenly distributed throughout. So you need to look for one where the particles are evenly distributed. Now, the problem with A, if you look, all the sugar particles are along the edges, okay, and the water particles are all in the middle. So that's not even distribution. With C, sugar particles are all at the bottom, as if they've sunk like a solid, and the water particles are above them. So again, that's not evenly distributed. And D is the opposite way around to C. So again, that's not even distribution. The one which shows evenly distributed particles is B. As you can see, the sugar particles are interspersed in between the water molecules, showing even distribution. So the answer is B. Next one. Diagram shows how to obtain pure water from seawater. Where do water molecules lose energy? So obviously you're heating at this point here, so they're going to gain energy here. They're going to evaporate and go through the condenser here, And the purpose of the condenser is to cool the vapour down. Okay, so that water passing through the condenser is going to get cooled down in this apparatus C. And I think that's enough just for a sample of multiple choice questions. Let me know if there's any other particular questions you want me to do, whether it's MCQ or paper 4 or paper 6.